Can everyone hear me? All right, so today we are going over files. I'll probably go also over how to do, go back over how to do libraries. I recorded that. It's available on Collaborate, but as we do the demo, I'll see if I can demonstrate that as well. So let's see, files. Yeah, so we're going to be doing files this week, and the next week we'll get into GUI, making GUI applications. So files. So right now, if you make a program and you shut off the program, what happens to the data you've gotten from the user? It disappears. What is that? Which type of memory are we working with, RAM or the hard drive? Everything's been done in RAM so far. So in order to preserve information, we have to save things in the hard drive. The way we do that is by writing files. Everything on the hard drive is really a collection of files. So that's what we're going to learn how to do today. And so files allow us to save and retrieve data from the hard drive. And so we can say that we use files to persist information from one run to the next. And if we didn't do that, you wouldn't be able to ever save anything. So the command to open a file is the open command. And we provide the name of the file, which is a string, which is really just the file name, just have in your file explorer. And then we have a couple other parameters which we can set, the mode and the buffering state. And mode and buffering are optional parameters. So go ahead and try this. Start up a Python console and put f equals open and put c:\text_some_file.txt. So that file doesn't exist. Let's see if we can open it. What do you get? So does that work? Yeah, it doesn't work because notice it says IO error. So we did exception handling, correct? Yeah, so you could actually wrap, and it's normally recommended you wrap anytime you work with files, you wrap that in a try except block and you look for the IO exception. In these examples, we're not going to do that because it adds a lot of, we just want to learn how to work with files initially, but that is a good practice when you're working with files, is to wrap it with a try except. In this case, though, we get an IO error. It says error number 22, invalid mode R with that file name. So we can't read from a file that doesn't exist. And also note that what that means is that the open command defaults to the read mode. There are several different modes that we can place, and in the open command, you put the name of the file, which in this case was the path. In this case, we have a path and a file name. By the way, if you put a full path, it'll look for the file at that path. If you omit the C colon and you just put a file name or a file name and some directories, that will be a relative path, which means that it will be relative to where your program's running. So starting with C colon will be the exact path. If you just put a file name or file name and some directories, it'll be a relative path. And so that's the name of our file, or the file in the directory is here. This mode can be any of these values. R is for read, W is for write, A is append, B is binary mode, and this plus, if you add it next to R or W, will make either one of these be read and write at the same time. So read mode, basically what that means is we can read from that file, but we can't do any kind of write operation. So the write means we can write to the file, but we can't really read from it. And the way a file works is it has this thing called a file pointer. And when you open a file, it opens a file and sets the file pointer at the very beginning of the file. And then if you're reading, it'll start reading from the beginning of the file. If you're writing, you'll be writing from the beginning of the file and basically overwrite everything. The append mode will actually put the file pointer at the end of the file when you open it and allows you to add to the file. And it won't disturb what's already there. And then binary mode, we'll talk about that in a second. And if you put the plus next to read and write, you can both do reading and writing file at the same time. So by default, the default is read mode, but if we wanted to write to a new file, we would use W. So the plus allows us to, so if you put plus next to an R or W, allows you to do both reading and writing. The B mode basically changes the way Python handles a file. Most of the time with files, we're dealing with them as text files. And what that really means is that we expect them to end with a carriage return, a \n. The actual way carriage returns are stored in your file depends on the operating system. So Windows uses actually \r/n by default. Unix uses a \n, and so does Linux. So it could get confusing if you're having to figure out which file it is, but oh yes, thanks, Richard. What Richard pointed out is if you if you use backslashes, you have to double the backslashes up because otherwise it thinks it's an escape character. So it would think \t as a tab as opposed to the first character of text. So when we're dealing with text files, we're assuming we're going to have a character to return at the end. But let's say we're dealing with an image. Well, an image is basically a collection of pixels, and what a pixel is basically 3 numbers, which is red, green, blue values. And it is entirely possible, and \n corresponds to the value 10. And it's possible that one of those red, green, blue values could be 10. So if we read an image as a file, it would skip over all the values of 10 and would completely mess up your image. So if you're dealing with something like an image, you have to open it with mode B, because we have to treat it as a binary file. And then it won't skip over the 10. So another optional character attribute we can set besides mode is buffering. It defaults to 1, which is true, and basically 0 is unbuffered, 1 is buffered. And what buffered means is that rather than reading just a little bit from the disk drive and then going next, buffered will, even if you're just reading like the first 2 elements of a file, it'll preload into a buffer like 100 characters or 100 bytes, and wait for you to get them from RAM, and we'll deliver them from RAM. What buffering does is it basically reduces the number of read-write cycles on your hard drive, and especially if you have an SSD, you want to minimize your read-write cycles because it has a limited amount that it can do in the long run. And then spinning hard drives. Also, every time you start and stop them, you put wear and tear on the hard drive, and eventually it fails. So you kind of just, generally speaking, just leave that one alone, and it will default to buffered reading, and that's the most efficient way of reading from a file. So let's try this. In your shell, go ahead and open somefile.txt for write, and then write hello, then write world, and then hit close. And I'm going to try this too, just so I can follow along. I can spell properly. Okay, if you get this, what it might be happening is that the shell is running, is running from, in my case, it's from my program folder, and it's not, and I probably have some permission things assigned for it. So I'm going to suggest we do this. Let's make this a program instead, and I'm going to open a file. And I'm going to suggest saving on your desktop or some directory that you know, and create a folder on your desktop called file demo, and store. We're going to put everything in a single file. So I'm creating this file folder in desktop, and then call this also file demo.py. And then I'm going to run this. And just to show you what the directory looks like, here's, I'm going to do it this way. Here's from file demo.py, this program that's sitting inside of file demo. When I run this, the question is, where does some file going to end up? And notice that when I ran it, somefile.txt shows up in the same directory where this program is located. By default, if you make a relative reference, it's going to put it in that directory. And if I open up that file, where'd you go? we can see what I typed here ends up here. But why is it on one line? I have two write operations and it ended up on one line. Can anyone explain why that happens? Can you all hear me? So any idea why this ends up on one line? Well, the reason is that even though we have a write on two lines, unlike print, write does not automatically put a carriage return on it. If I were to put in here a \n and run this program, oh, that was a /n. Let me put a \n on here. Now notice that it comes on two lines. Does that make sense? So if you want a carriage return in when you're writing the files, you have to explicitly put a carriage return in there. Yeah, and if you run it from the command line, try to put that file actually in your Python directory. If the permissions on your computer don't allow you to write directly to the Python directory because that's a system location, you'll get those errors that we saw. So there's no write line. We have to just put a \n with the write command to get the carriage return. And so let's do this one as a program. I'm going to make a new program. And we're going to open this up for write. And then, and you can put whatever you want. Blah, blah, blah would be fine. And then I'm going to put a \n. And I'll just do that few. Oh, where'd you go? I'll just do that a few times. So I'll get maybe 3 or 4 lines. And then we're going to f.close. You always want to close your files because that's what actually makes sure that everything's written. And I'll save that. Be multi-line file demo.py. And then I'll run that. And if I look, I can see multi-line file.txt is created, and I have 4 lines with carriage returns on them. Does that work for everyone? So that's kind of how you generally will work with multi-line programming. Is you'll open or making a file. You open the file, and then you just write the same way you would print. You just kind of write to the file. Instead of showing up on the screen, it will show up in the text file, and that's how you create your text file. Does that make sense? So now reading from a file. So that we've written to the file. Now we want to be able to open a file. And to open a file, we will use read or W. Of course, R is the default, so you could also just omit it. And so what I want you to do is make a program, and we're going to read 4 elements. Well, actually, let's just do this. See if we can do this from the, well, we can't really do it from the command line because we need to be operating from there. Oh, sure. Do you need me to go back and show you what we had so far, Ryan? So let me see. So I'm going to make another program off of this. And we're going to open up our file. And let's see, what did we call it? I call, yeah, sumefile.txt. So I'm going to open up sumefile.txt for read. And then I'm going to say f.read 4. If I just do that, though, I need to store this somewhere. So I'm going to modify this by just saying text that we get is from that. And then I'm going to print this text just to see what's in that file. So we're going to do it this way. So if we look at that, so now I'm going to run this, and let's see. Maybe I'll call this on readdemo.py. Why does it say hell? Is it just angry at me, or what did it do? Yeah, so because of the 4, what the read function does in this case is it reads the first 4 characters. And so if we do a read and we put numbers in there, it'll read, what it'll do is it'll end up reading 4 characters. Go ahead and remove that 4 and then run it again. Notice if we just do a read with no numbers in there, it reads all the way till the end. Does that work? So the reason why we have that read a function and we can read a certain number of characters is there are some file formats where, for example, the first 10 characters are one thing, then the next 5 characters are something else, then the next 15 characters are something else. And it's organized in columns that way. The disadvantage of that approach is it actually is a tremendous waste of memory on the drive because often you have to pad everything in those columns with extra spaces or zeros in order to make that work. So you don't really see a lot of files today using that format. So we don't often put in something that says read a certain number of characters. Usually we're using this format and reading the entire line. So if you read 4, you'll get 4 characters. If you just do a dot read, you'll get everything from where the file pointer is to the end. So notice here it says "oh world," and the reason why is because if you do it the way in this example it's done, rather than doing it in a file, it actually it consumes 4 characters with the read 4. The file pointer is now sitting at the 5th character, which is the O. And then when you do another read, if you do a read to the end, it'll read everything from the file pointer. So you have to kind of keep in mind where your file pointer is in files when you're working with them. So f.read reads the entire, all the way to the end of the file. With a number, it reads that number of characters. So that's one way of reading our file. Now, if you have a really large file and you try to read that in memory, if you have so for example, let's say you have a 2 gig hard drive. If you had a file that was 1 gigabyte, or let's see. Well, basically, your hard drive has way more memory than your RAM. So it's very easy to have a file that can't fit into RAM. So often we don't just read the entire file in all at once, unless we know that it's going to be a small file. More often what we do is we read a line at a time. So we read to the \n. And so the way we do that is we use the read line command. So I'm actually going to do this with the multi-file because it makes more sense. So I'm going to go here and let's see. So that's our multi-file file. And so I'm going to make a program that basically we're going to f equals we'll read that to read, and then we're going to say text is equal to f dot read line, and then print text. I'll call it readline demo.py. And we can see it read that first line. And just to make it clear, I might just do this. I'm going to put a 1, 2, 3, and a 4 here. And we see that we do, in fact, get the first line. Let me know when that works for everyone. Okay, so we can see that we can use read line to read one line. There's also, and that's actually going to be the primary way that we read a file. And I'll go ahead and demonstrate that here. Actually, no, we do that later, so I'll hold off. So that's read line is the way we often are going to read a file. Um, there's also a method called read lines, which reads all the lines in a file. So let's modify our program a little bit. And we're going to say, we're just going to add an S here and then run that program again. So now I'm doing read lines with an S. What changed? Yeah, it's reading all of them at once. What is this thing that we're looking at here that it gives you back? No, this isn't the code. It's a list. So text is a list. If I put text index 2, what am I going to get? The second line? The third line, right? Because it's zero based. But that's a list, and you can actually, get hold of any of the lines that you want just by indexing them out of there. So read lines is kind of useful. It returns a list of the lines that are in there, and you can index through them and grab whichever line you want. So one of the things that we've seen is at the end we do file.close. The reason why you want to always close your files is because a couple of reasons. One, when you close a file, if there's anything left in the buffer, it will flush that to the file and make sure that that gets captured in your file. So if you don't do that, you could lose elements on your file. The other reason is that often, if we were working with files that were on a network server and our application was being run by multiple people that were accessing that file, you would want to be able to open that file, grab the information you need, and close that file as fast as possible so that it remains as available to everyone else. Standard Windows operating systems, you cannot open a file for read by more than one computer. So because it puts a file lock on it. So when we're doing certain operations with files, we want to open and close them as fast as possible. So everything makes sense so far? So the next thing we want to do is, okay, we got files, we want to read through them. How do we open them? Well, here's a little example where we're going to open a file and then we're going to read a character and we're going to send that character to this process function, which will take a string and just display it. And it's, you could actually put whatever you want to do with this string, and you could use this to iterate through and use it. Often we'll put this code, we won't necessarily do this in a function. We'll just put whatever we want to have happen inside the while loop. But this is a nice, elegant way of making it look too. So let's let's make that program and run it. So I'm going to make a new program. So this is called a priming read. We read, notice that these two lines are identical. In fact, I'm going to copy this one and paste it over so I can make sure that it's identical. It's called a priming read because our while needs to check to see if there's anything coming from the file. What this does is it reads one character from the file, and then our while loop checks to make sure that we got something. If you have an empty file and you were to read from it, what you would get is basically an empty string here. And an empty string evaluates what a Boolean perspective. So what does an empty string evaluate to? Correct. It evaluates to false. Zeros evaluate to false. Empty strings evaluate to false. Everything else evaluates to true. So if we got something here, this would be true, and then we would do the process, and then we read the next character, and we see if we get something. At some point, we don't get it from the file. This evaluates to false, and then we're done. So if I run this one, we're going to call it iterate character by character demo. You can call it whatever you want. Got my parentheses, Python 3. And then what did we get? We got every character one by one. Notice that the backslash n ends up doing a character turn in here. That's why it looks the way it does. So this is reading a character by character. Does that make sense? That's what we just did. Another way we can read is try this one. Change it to read line. And in this case, what we're going to do is the priming read process works, but as programmers, we hate when we have duplicate lines of code. So in this one, what you're going to do is we're going to change it. I'm going to save this as line by line. And rather than doing a priming read, we get rid of that and we do a while true. Normally, how many times would a while true run? An infinite number of times. And this is a pattern that's often done in Python. You'll see a lot of while trues. And then what we're going to do is say, if not line, then break. What the break does is it'll break out of this loop. And so this is a common pattern with Python. You'll see a lot of while trues, and somewhere in there, there'll be an if statement that will check for the condition where you want to stop, and you'll just do a break. So here we're going to read a read line, and then we're going to pass in a line now. And maybe that was a problem, Ryan. So we're going to pass line into process. Process line will be copied into string. String should print. So I'm going to save that and then run it. Should get each line. Let me know when that works. So, and this is probably going to be the most frequent way. So you still have, could you copy and paste your code into the chat window, Ryan? So look at the first line of your function. Okay, anyone see where the error is? Did you get it, Ryan? Yep. It's always something small. So, thanks, Ronald. So, this is going to be the most frequent way you do that. You actually iterate through a file, and what we often do is like you read a line like this, and then if you want to be able to separate these out, you might actually say words is equal to line dot split, and then now I'm going to pass words in. And you can see now I've got every single word. This is all indexed out now. I'm reading line by line. I've got it individual words. And you can use your code to then actually address every single one of these elements separately. So this is a powerful thing to do too, is splitting. If we had a comma separated value file, we could actually, so let's say I had something, say like 35.00, comma 101 dot 123, comma Albuquerque, and I had 35 or 36, comma 01 or dot 01, comma 102 dot 153, comma Santa Fe. I'll save that as my multi-line file. And I were to run that. And then I were to split not on a space, but on a comma. What would I get? Well, notice I'm splitting on a comma and I'm getting each individual element here. And I would actually probably name this like this because it's it's not really words, they're elements in here. And so I would probably call it elements and do it this way. It doesn't make a big difference, but my code reads a little better. I'm getting a latitude, longitude, and description, correct? What do you think we're going to do with our next program? Yes, so in our next program, we're actually going to have more than 2 points in here. We're going to have, I'm just going to copy this like that just to kind of demonstrate. We're actually going to have multiple points. And what you're going to do is you're going to read them, you're going to have them in a file that you're going to actually just type up this file with a text document. And then you're going to have your program read these points. And then given the user's location, you're going to figure out which one they're closest to. So that's going to be the next iteration of the program using a file. And if you think about it, imagine we're in an airplane and the pilot is no longer functional and we need the airplane to land itself. Airplane has to do a couple things. One, it has to figure out where it's at. That's a GPS system. And then it's got to figure out what the closest airport is. If it had a file of where all the airports are located, it would be able to get that latitude and longitude, find which one it's closest to, and then fly to that airport. And then you could imagine you could even put like radio frequencies in here, and it would be able to automatically call that airport, tell it that it's coming in for an emergency landing and it's pilotless and it needs the runway cleared. Does that make sense? Now imagine, now think about this. You could go take the course, the Internet of Things course that Carrie Bruce does, and you could learn how to write the code also in Python to control the actual ailerons and flaps and read all the instruments. And you could actually write with Python and a Raspberry Pi necessary to fly that airplane or drone. And you could actually use this kind of code to make a waypoint system to fly a drone, or actually possibly do an emergency landing system for an aircraft. And really, you're not that far away from the fundamentals to do this. As far as set up the whole, obviously setting up a program like that and making it testable and reliable and all that is something that a full big up company can do. But you're not far away from understanding the fundamentals of how that would be done. So, uh, so this gets kind of cool after a certain point. Okay, so that's one way. Let's continue on and look at other ways of reading files. But I wanted to highlight that because that part is what we're going to use in the next program. Um, Another thing we can do is I would save that, by the way. Don't modify that one. Make a copy. And another way we can read is this way. So try this. Type this one out. Say for char in f.read process char, and you should again. We're getting a read like that. So do that and let me know when that one works. No worries, Ryan. See you when you get back. In fact, why don't we do this? Let's take a 10-minute break, and then we'll continue on at 2:30. And meanwhile, I'll try to make this one work. Okay, so did that work for everybody? Are you able, do we get individual characters again? Cool. So you can see the difference is this does an f.read, and you might wonder, how is that different from, so the difference is that here we're doing a for loop, and a while back, what we did is we read a single character and used a while loop. So the primary difference here is we're doing an f.read. And if we do, so which is more memory efficient? Where we're reading one character, or if we're doing this f.read? Yeah, if we read a character at a time, we're only using up one, like basically 2 bytes of memory inside of our RAM at a time. If you do this f.read and you have of a 2 GB file, you'll end up reading, you have to put that whole file in memory at one time. So generally speaking, we kind of want to avoid using just f.read open close parentheses, because it brings in the whole file. And the only time you really want to do that is if you know that file is small enough to fit in RAM. But here basically it reads in the whole file, and then we go character by character, and that whole file is in memory at one time. Try this. Say, for line in f.readlines process line. So again, we're not using a while loop, we're using a for loop. And you should get that. And then same question, which is more efficient? Where we used read line, or if we do read lines? Actually, that previous read line method that we use is going to be more efficient. Again, read lines ends up reading the entire file in, and then it just breaks it apart into a list. But it does keep that, it has to read that whole file into memory at one time. And then to hold that list, it's got to keep everything in line in the memory at one time. So read lines is, again, another one where if you know your file is small, it would work. And if it doesn't, then if you don't know it's going to be a small file, probably don't want to do read lines. Probably want to read one line at a time. And I would say, generally speaking, when you're working with files, reading a line at a time is probably the safest way to do it. Does that make sense? Everyone ready for me to go on? So memory can be an issue with read and read lines reading a very large file. They read the entire file into RAM. If the file is large, use the read line method. You can also use reading a certain number of characters at a time. And then there's also this process called lazy line iteration. We're not going to type these in. I'm just going to talk through these, um, and provide these to you for future reference. We're not primarily going to use these methodologies, but they work as well. So here's another way. There's a library called file input library, and the file input library, if you can here notice, it looks like where you're reading from the entire file like we did before. But what you do is you say for line and file input dot input, so referring to that library using its input function in process line. This uses an iteration pattern that will actually bring in one line at a time. So if you wanted to use this approach in the programs, feel free to do so. It's memory efficient and it's a good way to go. But it basically extends the normal way of doing it using a file input library. If you did that, you'd get one line at a time. Does it make sense? Another way that you can read is this way. Is you can actually say for line in F, and I believe, let's see, this in your text was is also lazy line iteration, and that will process a line at a time. So you can actually just say for line in F, process a line. And so I believe that is a different way of doing it as well. And it's also nice and concise. And if you did that, you would get the same sort of thing. And so that's basically how to read over a file. Any questions about reading from a file? Okay, so what I'm going to do next is I'm going to review, I'm going to show um, how to work with um, libraries. And so I'm going to, on my desktop, I'm going to create a new folder and I'm going to call it library demo. And let's say we have this program and we have a class that and my class maybe has an in a method. And we have a couple of and we'll just say self dot, oh, I forgot my self. So typical init method, we have some defaulted values here that will be set into the self variables. Maybe I'll just call this value because we only have one of them. And then maybe I have my getters and setters. Standard setter takes a parameter and I just set that parameter into the self variable. And then make a setter and getter for our string value. we go over, we went over properties, correct? So does that look like the way we've been generally building our classes? So once we have this class, we might do something like this. Um, Sorry, programming language. So I'm just making a silly little program just to kind of see what this does, and I'm going to save it in this library demo. I'm gonna call it library demo driver.py. And if I run this program, we can see it kind of works. 2 has all the defaults. 1 has what I assigned into the constructor, and it just generally works. No, this that we really have 3 ways of getting everything. We have the attribute, which is this one right here. We have the get method, and then we have the property. We could actually make these unaccessible by putting double underscores in front of them, but we'll just leave it like this for now. Does that make sense? These 2 are basically identical. The only difference is I've got a 2 instead of a 1. You may have to, Ryan, you may have to stop and restart, collaborate. Sometimes that helps. Okay, so all that was just to kind of review how a class kind of goes together. But now let's see how we make a library out of it. So very simply, we're going to create a new file. And we're going to take this whole class, remove it from main. Sure. Okay, so I removed the class and placed it in its own file. I'm going to save this file as, I'm just going to call it my library.py. So notice there's no main part of this program. If you execute this, it defines a class, but it does nothing else. And all I do is I'm going to import Let me bring up. I'm going to import this library here by saying import my library. And then I'm going to put, in order to get access to my class, I have to put my library dot my class in front of everything. And if I run that, it still works. So all you do to make a library is basically just copy the things that you want in the library and then import them. And just like we did with our math class or math libraries or other libraries, you put dot and then the thing you want in there. Does that make sense? Does that make sense, everyone? Anyone see a more, maybe a neater way to do that import so I don't have to type my library dot in front of everything? Could I do this a little better so that I don't have to type this all the time? Yes. If you do from my library and then you list what you want to import my class, you now don't have to put my library dot in front of everything. And often we do that because it's going to look a lot cleaner and it's a little more specific. Now, if you have multiple classes or multiple functions, you have to put all the functions and things that you wanted in here. Does that make sense? So this works for classes. It can also work for functions. Let's say that I wanted, here I've got some duplication. It would make sense to make this into a function. So I'm going to turn this into a function. I'm going to copy this, and inside of my library, I'm going to define I actually don't want to use object because that's I'll just use obj because that's a keyword. And now what I can do is and I'm going to import my class and display info. on, do what I tell you to do. Oh, this happens sometimes. I've changed this class. Um, if I stop this, I think this will redefine it. Nope, it doesn't. What's happening here is it's giving me, it can't find the object. You may encounter this. Encounter a problem with your class. What happens is in here in PythonCh, once you import a library, it's going to put the compiled version of the library in PythonCh. Sometimes if you have troubles, what you need to do, if you redefine the library, you need to delete the library in PythonCh and then, or cache, and then rerun the program. Nope, that wasn't it. Did I not save? Might not have saved. There we go. I forgot to save this after I made the changes. That was actually the problem. So now I've got both a class and a function. So you can make a library that has a bunch of classes and maybe some related functions, all put them together in one file. And then you can use that to kind of make, you know, some little frameworky type of libraries that have all related info. So, you know, this display info function really depends on a class of this type to be in here, and if it is, then it'll run through there. You know, you could even fancy and say if you could put in a check here to make sure this object was, you know, of that class type. I won't get into too much complexity into that, but all these things could be set up to rely on each other and that library and make a useful library. Does that kind of make sense? Can everyone hear me? So that's how libraries work. So that's pretty much what I have for today. Next time we'll continue on with files and probably look at a little bit more detail how to read a data file. And we'll go over the next assignment. Next assignment's basically to read a file and pull in the information. You're going to put multiple points and then find the closest point. So that's all I have for today. Thank you.